In today's class, we are going to learn a new topic, and the topic is gravitational field and force. We will take it this way. First of all, we are going to learn what gravitational field is all about. From there, we learn what gravitation is all about. Then we move on to the Sir Isaac Newton's proposal that governs the universe. That's the next one. From there, we now understand what this is all about. So let's begin. But before I go into all that, remember to belong to this community, belong to this family of great learners, great teachers. Subscribe. Give me some thumbs up as sort of encouragement. All right? Push on the bell button for constant notification. It would cost nothing. Don't forget to share with your friends, networks, and students. That's all I ask. That's all. And then support me in whatever way you can. I will appreciate. Promote this channel, please. Thank you. All right, let's begin. Gravitational field. What is gravitational field? That's the question that will come to your mind. What is the meaning of gravitational field? It simply means a region around a mass, a region around a mass, or a space around a mass. And what happens then? In which the gravitational force of the mass can be felt. This region or this space around a mass, the gravitational force must be felt. That's what it means. So when we mention gravitational field, let your mind go through it as a region or a space, all right, in which gravitational force around that mass, around that body, around that particle can be felt. Because mass here does not just represent a quantity, it represents a body, a particle, an entity, around which some amount of gravitational force can be felt. That's all. That's all. All right? If we have understood that on the planets, and when that happens, it attracts them, and then keep them. It keeps them on that particular position they are supposed to be. That's what it means. The force of attraction between the sun and the planets maintain the positions of the various planets in their respective positions. That's what it means. Because it is a force of attraction. Gravitation is a force of attraction exerted by a body on all other bodies. Take notes. If that explanation is not clear, put it in the comment section. I will come back to it. All right? So let's move on. What happens? It is this gravitation, it is this force of attraction that keeps the planets together, that keeps the stars together, that keeps the galaxies together, and may have some amount of influence when we start discussing black hole. All right, we're not going to that now, okay? That's a bit advanced, but I'm going to touch it because I'm here to feed you with different concepts in physics. So look at it. That's what happens. If we have understood this concept, let me tell you, it is actually this concept that Sir Isaac Newton leveraged on and then proposed this universal law. And what does it say? The universal law is very simple. It says that every no matter how small the body is, every body, every particle in the universe will attract every other particle with a force which is proportional to the product of the masses of the particles, and then inversely proportional to the square of the distance separating them. That's what Sir Isaac Newton proposed, and that law holds up to this moment. Come on, it means a lot. In the scientific world, it means a lot. So when that happens, we have some respect for Sir Isaac Newton for proposing this law. All right? he didn't stop there. He said that this line must act. This force holding these bodies together must act along the line joining their centers. It must act along the line joining their centers, the centers of these two bodies, not just ordinarily, anywhere. No, it must join the centers of these two bodies. And also, it is also an example of the inverse square law. That's what it. And to illustrate everything we have just said, look at it. This, the first particle with mass m1, second particle with mass m2, each of them exerts an amount of force. But this force is attractive. It's not repulsive. It is attractive force. So, law of universal gravity or constant has to do with attraction. And that's why we have gravitation. Don't forget. So, if that happens, Sir Isaac went on to propose a mathematical concept that will enable every science-inclined individual to calculate problems happening between two bodies in the universe. That is it. The force between two bodies in the universe, their distance apart taken into consideration, can be calculated using this. The force is directly proportional to the product of the masses m1 and m2. But what happens to the distance separating them is inversely proportional to the distance separating the two masses. That's what happens here. But if you check very well, we cannot use this to solve any problems because of the proportionality sign. Therefore, there is need to convert this proportionality sign to equality sign by introducing a constant. And that constant is referred to as gravitational universal constant. G, connecting the force, the masses m1 and m2, and then the distance separating the two masses, or two bodies, or two particles, so to say. If all these parameters retain their usual meanings, we now have F. Okay, where G is given in terms of units, Newton meter squared per kilogram squared. And that's all. That's all. And this is very clear. Alright? So that's what it means. If we have watched up to this moment, definitely we may have found some values. Why don't you subscribe? Encourage this young man. Put on the bell button for constant notification. Subscribe. Share with your friends, networks, and students.